Large gear transmission. How is it installed in a simple workshop? Each 5 cm thick steel plate is unloaded from the truck, although the workshop looks simple. With only compacted earth as flooring and limited space, the equipment is quite complete. The products manufactured are of high quality. The master marks and cuts steel. Not everyone can do this job. One must be familiar with the dimensions of each part. When cutting materials, steel savings must also be considered. Just a slight position adjustment can make use of an extra useful steel piece. After all, a large steel sheet like this is not cheap. After marking the cut lines, a drill is used to mark the points. Only then is the cutting process started using the oxyacetylene cutting method. Oxycutting is a simple and easy-to-use tool, regardless of shape. It can be machined, even with supporting tools. The master never takes his eyes off the cutting line for even a second, always watching every detail. Cutting a circle in the center, just place the locator at the center, and a perfect round hole can be cut. The master is as steady as a mountain. The cutting line is incredibly precise. The cut parts are gathered on a workbench, using an angle grinder to smooth the sharp edges. Next, install the side panels with 3 half circles, standing upright on the base, adjusting the position according to the drawn lines. Tack weld a few points for temporary fixation. Just holding it firmly is enough. Then install the other side panel, using the same method, aligning it with feet. Next, install the short side panel, adjusting it to the correct position. It's a bit difficult to fit it in, but this is a simple task, using a large hammer to fix it, showing it the power of force. After adjusting to the right position, tack weld a few points to secure it. Repeat the same for the other side. Anyway, the cut surface is not very smooth. A large hammer is the only way to fix it. Weld a few points to secure it. Proceed to weld all the gaps completely. It looks like only a little welding is done. I wonder if it will crack over long-term use. Use a crane to assist in assembling the upper part. Before installing the top cover, weld 2 protruding steel bars. Helps with positioning and securing during assembly. After alignment, continue tack welding to secure. Cut a steel plate with a slanted surface. Place it into this gap. The small square block in the middle is an observation window, or it could be a backup oil filling hole. Welding it together will form a trapezoidal structure. After completing the upper assembly, gently lift it with the crane. The previous tack welds will break apart. This is a large gear transmission. The bearings used are also quite large. The steel plate cut earlier is used to extend the bearing mounting position. Lift it with the crane and place it next to the gearbox. Stack it onto the pre-installed half circle and weld it in place. The other side is processed in the same way. The upper part is also reinforced at the bearing mounting positions. Additional steel is welded around to create a protective edge. This edge is to leave space for bolt installation. Flip it over and weld each joint carefully. After welding, transfer it to the lathe for machining, mainly to flatten this surface. I don't know how they align it, but the surface machining process takes a long time. After several hours of turning, the surface becomes perfectly polished. Cut a few square steel plates as support bars, further reinforcing the gear shaft positions. Each bar must be placed directly under the half circle. Next is machining. Drill holes on the top assembly surface. Use a small drill bit for initial positioning holes. Then expand the holes with a larger drill bit. These holes are quite large. A total of 3 drill bits were used to achieve the correct hole size. The holes are also quite deep. When using a large drill bit, speed needs to be slowed down. If the drill bit breaks, it will be very difficult to remove. On this side, the master is still machining the protective edge, using 4 steel plates as supports. After drilling all the holes, cut off the excess steel. Then assemble them together. Use a crane to lift them onto the drilling machine. Continue drilling holes in the predetermined positions on the top cover. This ensures perfectly symmetrical bolt holes. If not done this way, the holes might not align properly during assembly later. Place gaskets on the contact surface. Then tighten with bolts. Move it to the lathe. Machine the outer surface flat. This part is not easy to machine at all. After finishing the flat surface, continue machining the bearing groove. Once the bearing groove is completed, apply a coating inside the gearbox. Attach a rubber gasket to the protective edge. Then the gears can be installed. Install the bearings first. Use a crane to slowly lower them into the groove. Try rotating slightly. The fit is excellent. The final gear is quite difficult to install. The masters adjusted several times, only then was it installed precisely. Test rotating the gears. Check if they mesh properly. If there are no issues, proceed to grease the bearings. There is no grease gun, so the master meticulously applies it by hand. Every gap is filled with grease. Then close the gearbox cover, tighten the bolts. Work on the inspection cover. Heat the spindle key. Using the principle of thermal expansion, heating is the fastest and most effective method. Observing, this part fits perfectly into place. Then insert the pin into the groove. Attach a gasket to the sealing cover. Then install it onto the bearing position. Tighten the bolts. Apply the final coating. Seal around the pipe opening with adhesive. Use a transparent mica sheet to cover it. Thus, a super large gearbox is completed. What do you think? Is the quality of the products they make good? See you in the next video.